Hey, can you guys hear me?
Yes, sir.
Okay, so I think there was a problem with Zoom. It got disconnected. All right, so we discussed about uh, अरे यार. All right, so we discussed about data frames and how to create it, when to create it, what are the advantages, and also the different transformations. Are there any questions, Venkat, on the data frames?
Sir, no, sir. Sir, what about machine learning in this data frame, sir? I mean, role.
Machine learning.
Yes, sir.
So machine learning is basically that's a different um, topic altogether,
Okay.
right? So when you run the machine learning, any machine learning model, any machine learning algorithm, you need a data, right? So when the data comes from the different sources, and the you will process the data, you will transform the data using the data frames and the data bricks, etc. And then you will give such a way that that data can be helpful for the machine learning model to take that data as an input and predict something.
Yes, sir.
Okay, so that's the role of machine learning, because machine learning models cannot read the source data directly and they cannot use that. Right? You need an intermediate layer to process the data in such a way that can helpful for the machine learning.
Yes, sir. Thank you.
Okay, so that's basically a data scientist role.
Yes, sir.
Okay, so now we are done with the data frames. So now we will do with the RDDs. Okay, so in today's session we'll discuss more about RDDs and how to create RDs and what are the different uh, transformations we can do on top of RDD. So what is RDD? I think we covered a very introduction of when we're discussing Spark internals, we covered about RDDs. So what is RDD? Can somebody remembers?
Already is a resilient distributed data set. RDD is an immutable distributed collection of data.
You're right. Yeah. So RDD is basically a foundational structure of data structure of Spark. Okay. Without RDD, there is no Spark exist. Okay. And data frames are another level of abstraction APIs out of RDD. Okay, to work with Spark. Okay, so now let me quickly touch upon what is RDD. So as you rightly said, RDD is a resilient distributed data set. It is a foundational structure, data structure of a Spark. Okay, anything you wanted to convert to process with RDD, sorry, you want to work with RDD, so it has to be in the form of RDD or the data frame. Okay. Okay. And also we discussed some of the features, which is resilient, partition, and distributed and immutable collection of data. Okay, we discussed about what is really resilient, what is partition, what is distributed, and what is immutable. Okay, so now here the underlying you need to remember one thing is the immutable. So once you define RDD, you cannot change an RDD. Okay, that's for sure. You can create another RDD out of an RDD, but the original RDD that you created can't be modified. Okay, that's one thing to remember. Now, also we discussed about some of the operations we do on top of in the form of transformations and actions, right? Basically, as you can see, the transformations often create a new distributed data set from an existing, right? So that means they create a new RDD from an existing RDD. Why they created new RDD from an existing? Because RDD is an immutable. You cannot change RDD once it created. Okay, and the actions are mainly basically the sending the results back to the driver. Okay, so this is what called a lazy lazy transformations. So when you do a transformation, unless you take an action, the result is not going to the transformation is not going to be evaluated, and the result is not going to come back. Okay, that is why it's called a lazy transformations. Okay, once you do the action, then only you get um, the compute the transformation is going to be executed in the compute and the memory, and you will get the result out of that. Just defining a transformation doesn't mean that you it's already processed and readily available. Okay, that's another thing to remember. Okay, so now when to create RDD, we know already it's an unstructured where a transformations are low level and schema is unimportant, right? Now, what is the real use case of an RDD? Let's assume that you're getting a social media data, right? There is a product being launched in the social media, and somebody likes the product, somebody comment on the product, and somebody given a response to that, and some that comment, so on and so forth happens in the social media, right? Now, as an organization, you get the social media data, and you wanted to know how many people like the data, how many people given input to the data, and what are the different comments that you can improve the product further, correct? So now here the schema is not important. We don't know what schema it is, whether it is a ID, whether it is a name, whether it is a string, whether it is a integer, doesn't matter. The schema is a very least important here, right? And also the transformations are very low level, right? We are not going to whatever the comments have come, we are not going to be manipulating too much, because that is not the intention. We wanted to read the data quickly, and then I wanted to know how many people like the data and how many people did not like it. What are the some of the suggestion I got it from my social media. That's it, right? And if you see, social media data is very much unstructured. You will have a lot of kind of a semi to unstructured kind of a data. Or maybe somebody post an image out of that, right? So all this can happen with the social media. So now in that case, if you go to create a data frame out of that, you're going to spend a lot of time, right? And when you work with the analytics, data analytics, time is most important aspect. I want the result immediately. And sometimes it may happen that somebody still some comments are coming. You have to do a streaming and then read those comments as well. All right. So in that cases, RDDs are very efficient, and you can quickly create RDDs, and then you can work on that. Okay, so now how do you work? Let's say I got a social media data, right? I want my management is asking quickly. They wanted to know, they launched the product in over the weekend, and there are some, some comments, somebody likes, dislikes, and all, right? So They wanted quickly know the statistics of that so that they can take a further action out of that and they can improve the product efficiency. All right. So that is where you have a transformations come into picture. Okay. So now how do you apply the transformations? Right. So how do we create RDDs, and how do we apply transformation, and what are the different transformations are available? Okay. So remember, data frame is very much structured. We have seen hundreds of functions and transformations you can do, right? But when it comes to RDD, it's very much unstructured, and you may not have those many transformations that are available as part of uh, data frame. Okay, so now let's quickly discuss how to create an RDD and how different transformations can be applied, and also we can see what are the some of the limitations, and then see how do we overcome those. We can as compared to the data frame. All right. So now we know what is RDD, when to create. So what are the different ways to create RDD? So RDDs can be created by input data, right? So that's even we discussed when we uh, as part of data frame. Also data frame also can be created as an input data, and also can be created by a file, right? Similarly, RD can also created using input data, and you will pass the data as an parameter, right? So you can see spark context parallelize. Okay, so this parallelize is what going to be create the RDD. So that means you are providing a data to this parallelize function, which basically distributes the data accordingly and then process that. Okay, and also there is another way within the Spark context where the test file directly you can upload and create a RDD as well. Okay, so now let's deep dive. Let's quickly create an RDD. Okay, so my cluster is ready. So I created a cluster. My cluster is ready. Now, similar example I have taken. If you see data, I have taken a first name, last name. Okay, basically it's a two values, right? It's a kind of a list. I have two values. Okay, I have defined, and then I created a RDD. So, okay, so now before we create, let's understand what is a Spark contest. As you can see, Spark context having multiple things. Okay, you can see remote context, and uh, so we are interested into parallelize, right? So let's go to parallelize. So it has multiple. You can see it can read from Hadoop file. There are so many stuff. It does the Spark context and creates a Hadoop RDD. Do you guys know what is Hadoop? Guys, do you know what is Hadoop?
Sir.
It's a big data, sir.
Correct. So before Spark, to process the big data, Hadoop was the first invented by the Google. Okay, Hadoop file system and MapReduce is the programming to process the big data. Right. Since that has its own limitations, to speed up the activity, Spark has come. Okay, so if you remember, if you see, Spark is not a replacement for Hadoop, but it's an efficient and another more processing, more fast. It's kind of an extension. Okay, so now you see parallelize is what we wanted to use. So what is that? Distribute a local Python collection to form an RDD, right? Using range of recommended if the input represents a range of performance. Okay, so now we don't have a too much of range. We just have a two values. Okay, so if you see it accepts a class, a treatable collection of distributed. Okay, and then this is num slices is number of partitions of the RDD is an optional, right? But otherwise you can give the number of partitions you want to perform to process this data, right? This is very important, guys. See, we are dealing with the um, uh, very less number of data, so this is optional, we can ignore it. But when you process a big data, you know that what is the size of data and how many partitions it makes the process more efficient, right? So in that case, you can use this you can use this parameter and give the number of partitions to be um, uh, um, the number of partitions to be created out of this RDD, so that the partitions it's processed that efficiently. Let's say you're getting a million records, or you're getting a million, are you getting a 1 GB of data, right? How do you process? You cannot process with the default partitions. You need to partition in such a way that maybe 10 or 15 partitions you create and then process the accordingly, right? You need to benchmark and increase or decrease the partitions accordingly. Okay, so don't worry about all this stuff, gloom and all. Okay, we will discuss later. But if you see, a simple example could be with the parallelize, they're giving a list of values and then uh, uh, creating an RDD out of that. Okay, now let's see, let's go back and create our own RDD. All right, so I have a data, the same the data I used with the data API data frame also. So we have a two first name, last name, and first name, two employees are there. Now Spark context parallelize. I pass this data to this one. Okay. Now let's see what output will I get. Now you see it's created a PySpark RDD out of a object RDD object. Right. If I give type, and I can see RDD object. Okay. So now how do I see what is there in this RDD? Right. So there is a print option is available, which is basically uh, now this is where you can see these many transformations are the functions you can see available with RDD. So once the RDD has created, right? So you can see RDD is created with this data. Now what and all different things I can do if you like hold on. Now you can see these many things I can play with my RDD. Right? The same things which are available with most of them are available with data frame as well, right? When we create a data frame and when we press control enter, we see all these functions, right? Similarly for this also, for what do you call the RDD also, all these are available. Now out of them, if you see, one is such is a collect, right? Let's see what it does. right? So it read the data and just created a whatever is the input I give, I just gave this. The output has been created. Okay. So now if you remember, till I didn't use print. What happened when I use print? The Spark job got created, right? Before you can see this now. Before the print, what it happened? Nothing. It just created an object. You see, the output is nothing, just an object of RDD. Right? So when I use print, then only it got created the object. Sorry, the Spark job has been created and then processed in the in memory. Okay. Now this is what called um, collect is what called action. So this is where you can say as action. So until you take an action, it's not going to be evaluated and the processed in the memory. That's what called these are the lazy transformations. Okay, this is very important concept, guys. So it's a very one of the frequently asked question in interviews. Okay, so now when I print and I got the what are the input I give. So this is available, this is evaluated and available in memory for me to process now. Okay, similarly I can create a another I think yeah. So and there is another way of creating is I can pass we already have an employee, right? Employee data. So I already from the Spark, just I use the text file to create RDD. And if you see it here, uh, right, you can see the same another RDD got created. Now if I use print, you can see all the data given a comma separated values. Right now you can see the difference over here, right? So when we create an data frame, and when we create a data frame and we do the print data frame, we used to get a proper column name, columns and rows, right? But here if you see, there is nothing like a column or rows. It's just a kind of a plain text with the multiple values, right? So you can see this is a one value, and then within this is one value, this is one value, right? And this is one value. So this is what the structure of a object structure of a RDD. Okay, the same thing if you see it here, manually we given the same thing. This is one value, this is one value, this is something like that. Okay. So now I hope you understand what is how to create an RDD. Any questions, guys?
No, sir.
Will you able to differentiate the data frame and RDD? Okay. So now we need to transform this data, right? So now if you see either this data or this data, we need to transform. Right. So this is not the way nobody would able to read and nobody would able to identify what's happening here. That similarly, if you get a social media data, it's going to be like this only, right? So this data has to be transformed so that it can give the meaningful output, and that can be useful for further in the either machine learning or in the report, right? So this is not a human readable, right? Nobody would understand these. Okay, so that is where the transformations come into picture. Okay, so now if you see if you see none of this data I can able to modify here. So for example, let's say I wanted to modify 35,000 into I wanted to increase to something else, right? So I cannot work with the same RTD. I cannot modify this one. But when we are working with the data frame, we could able to create it, right? We could able to create it another data frame, and then with the column and or with column we can able to modify this. But here it's not possible. The only way to work on this is to create a new RDD and then with an existing RDD. Okay, so now we created RDD. You can create another RDD out of this RDD and you can transform this data. Okay, so it takes RDD as an input and produce one more RDD as an output. Okay, so and each time it creates a new RDD when we apply any transformations. Okay, that is the power of immutable. Okay, and since it's an immutable, you cannot change an existing, and that is the nature of immutable that we understood, right? So if somebody asks what is, can you tell me how immutable works? This is the explanation. Okay, so now what are the different transformations are available, right? How do I transform this data, right? So this looks like a kind of a list of values, like for example, this is one and this is one, right? So how do I transform this data and to make it a meaningful? That is where you have a there are two kind of transformations that RDDs you can apply. One is narrow transformations. Narrow transformations in the sense it's a one to one. Okay, that means all the elements that are required to compute the records in a single partition live in a single partition of parent RDD. Okay, now if you see, this is our data and these are the partitions. Okay, so what happens when we apply these narrow transformations? It's again remains after applying the transformation also, it remains same in the single partition, and then with the same as the parent partition. You are not creating a more partitions out of that. Okay, and some of the examples could be map, flat map, map partition, filter, and union simple. Sorry, sample. Okay, so these are the kind of a narrow. It called a narrow transformations. Okay, and another one is wide transformations. Okay, so wide transformations are basically you have a mix of, you can see the elements required from computing a single partition may live in many partitions of parent RDD. Okay, so to do this, for example, if I want to do intersection, I want to read from multiple partitions of parent RDD and then make out of a new partition and then out to get the result. As you can see, the data comes from many partitions of this is the parent, this is the current, right? So the result comes from the multiple partitions and then accordingly it makes out of another partition. So this is called wide transformations. Okay, so some of the examples could be intersection, distinct, and reduced by key, group by key, join. All these are part of wide transformations. Okay, so we are going to discuss in detail. Okay, don't worry if you're not understand. Okay, so now let's deep dive into narrow transformations. So narrow transformation, the first one is map. So what does the map does? Have anybody already know what map does and any previous experience you guys have? Okay, so now let's okay, before I go in example, let's deep dive into map. So the map function basically iterates over every line of RDD and splits into a new RDD. Okay, so for example, if you see, uh, you can see these are the ones, right? So if you see, this is the one, this is the two, this is three, right? So and you can see now the output is in form of a in continuous lines, right? It's a single line. If I copy it over here, for example, and if I copy this output to a notepad, you can see it's a continuous, it's a line by line, it's a kind of a you can see it's a line by line continuously is can extend, right? And we will not able to read it. Okay, so that is where the first function is. One second, guys, I'm getting a call. Right, so first of all we need to break this. The first we need to break this and make it a readable, right? That is where map function will help. So map function basically it iterates over every line in RDD. That means this is sorry, this is one line and this is one line and this is one line, right? So it reads through the every line in the RDD. Okay, and using map we can take any function and function applied to every element of RDD. Now once we get the line of this each one, and then we can apply on top of the further transformations, right? For example, if you see this one looks like this, right? So now I got the output of this way. Now I can do anything on top of this, right? So that is where map will come into picture. Okay, so now how it works, right? So as you can see here in this example, the lambda is a we already know what is lambda function, right? Lambda is a dummy function which we can pass anything and process anything. Okay, so now what I can do using a map, I can pass a lambda function. So this x, you can see x colon, right? So that means for each item in x, right? So x is what? So each item is, what is the item here? So this is an item, right? This is an item, this is an item, right? That is what we put it. For example, if you see here also, this is an item and this is an item. Okay, now for x of each item, give me x plus x of 0 and x of 1. So what is x of 0 here and what is x of 1? So this is x of 0 and this is x of 1. Right? Hope you guys understand the arrays here, right? So in an array, what happens? You have a multiple values, and within that you have a positional like x of 0 and x of 1. Right? So this remembers x of 0 and this is x of 1. Now this is again when it comes to the next item, this is again 0 and this is again 1, because array starts with 0. Okay, so that is what we did it over here. Now let's execute and see. Okay, so let me execute this one first. Right. So if you see, this is what my input, right? So John Alex is what my input, right? Now what it did this gave me x plus x of 0 plus a space and x of 1. So what it does, it read through x of 0, which is John, it gave me, and then added plus concatenated with the space. So you can see there is a space out over here, and then x of 1, which is Alex, right? So now I got a proper name, which is first name dot last name. That means John Alex. Similarly, Brito John. Though I got a two elements in here, which is different elements of John and Alex. Now I mapped and combined these two into one name, which is John Alex. Similarly, Brito John. Okay. So now what happens is map function basically works with the each of those elements and then gives the date transformation accordingly. Okay. Now let's say you don't want anything, you just want a um, just you want the last name, right? You just need a last names like Alex and John. So what you do? Nothing. You just use the X of 1. That's it. Okay. So now if you remember, if you create, let's say you want just a name, right? Just a last name. Okay. So now what will happen? You see, you got Alex and John. You're not bothered about the first name, right? So this is way map function will help you to transform the uh, values in that list. Okay. So now moving on to flat map. So what is flat map? So flat map basically it's again a function. So to each of input element we have many elements in the output RDD, right? So within this here you can see this is one element, this is one element. Okay, so flat map, you understand this is a flat map is not a new concept. If you are from Java or C++, it's very much available, right? So within that it's basically flattens the structure, right? For example, in an array, I have 1, 2, 3, 4. All will be flattened and it will give you as a rows, right? As simple as. Okay. So now if you see, it's basically the most simple use of flat map is to split each of input string into words. Okay. So if you see, I'll give another example I created. So if you see, I have created my name is ABC or my name is, I can give John. Okay. So now what flat map does? Flat map basically splits, right? You can see my name is John. Okay. So now if you see it, I created a data frame out of that, and gives the flat map. It's again same thing. Lambda. I used split if there is a space, split them into multiple things. Okay, then I created RDD 5 out of that. So now once I create RDD 5, how do I read that? Right, I need a for loop for item in RDD 5 collect print item. That's it. So if you see, if you execute this one, see my name is John. Right now it got the string got split into my across multiple rows. Okay, so now why these are important? See, guys, when you work with the social media kind of a data, the data is very unstructured. You might have a product name here, you might have a person name is here, you might have something else here, right? So you need to map the data and you need to get each and every element out of the data, right? Somebody says that the product is good. Somebody says good. Somebody says um, product is not good, right? So how do I differentiate these three? The only difference between these two, here not is there, right? And here not is not there, here not is there. So that means this is a negative comment, this is a positive comment, right? Unless you understand this, unless you split this into multiple, you will not able to make it out whether it's a good comment or bad comment, right? So that is where you can use the map and flat map. Okay, and the only difference between map and they both are similar in a way, right? But the only difference is, the key difference is, map returns only one element, while flat map returns can be list of elements. Okay, and as you can see here is flat map returns a list of elements over here, right? Whereas you can see map here, it just gives you the one element. You can see either this one or this one. Sorry, no, not this one. Yeah, you can see it's one element at a time. Okay, you see, depending on the situation, depending on the use, depending on the need, you can decide which one to use. Okay, there may be situations. First, you will use the map, and then you will use flat map on top of that. Like for example, if you see it here, I can create another RDD. I can create another RDD, which is RDD flat. Okay, then I can create RDD2. Okay, and I can create a flat map, and I can use that. Right. So these are the situations you can create an RDD out of another RDD. Okay, because why? Because you cannot modify the original RDD. Right. Once the RDD is created with the name, that's it. You cannot be able to modify with adding a new colon or anything. If you want to do anything, you have to always have to create another RDD and modify accordingly. Okay, so now the filter, right? It's very obvious that we cannot always use the data as is. We might have to create filters, right? So filter is again another good concept. Filter is basically returns containing only the element that meets the predicate. Right? For example, if I have a list of values here, I want to find all the Johns. Or another example could be, let's say that if you see, I created a data with 2, 4, 6, 8, 10, all even numbers, right? Now I want to filter the data using the ones which I divided by zero, I get the zero. Sorry, I get the zero. Okay, so if you see it here, see 6 I got, because 6 is the only number. If I divided by 3, I will get 0. Rest all it will you will get the remainder. All right. So you need to understand the structure. Lambda x means for each item in the list. Okay, each item it will apply this logic going to be applicable. So 2, 4, 6, 8, 10. Each item is going to be applicable, and you will get. For example, if I give it over here, you will see multiple values. Almost all, because everything is can be divided by 2. And if I had a 9, let's say I had a 9 over here. Okay, now if I do that, you will not get 9, because 9 cannot be divided by 2. You will not get 0. Okay, right? Like this, you can, able to filter the data using filter option. Okay, now we have map partitions. Map partition, just keep it aside. We will discuss in further classes. Okay, to make a sense. Now the last one is union. Right, union I think is pretty much same across. Right, there may be the underlying concepts remain same. Right, so let me see what how does union helps you. Okay, let's say I wanted to let's say help RDD 6, sorry, 6 dot union. Okay, you can see it returns another RDD, right? And it's a simple you can use RDD union another RDD. It just duplicates the data. See, 1 1 2 3 1 1 2 3. It's not, there is no magic. For example, if you see, um, right, if you are getting a 2 2, right? Now if I create another thing, RDD 7, which is based on RDD 6, right? Union, and I can give RDD 6, right? Now I can give uh, print RDD 7. You see, 2467 just doubled, right? And another increment could be, let's say that I have a values, right? For example, in here, right? I want to increase, I want to double these numbers. How do I do? I want to double these numbers. Which function should I use to do?
Lambda function, sir.
No, lambda is correct, but out of the just give me a second. Okay, so lambda is good, but with the flat map, which function will use to increase this to 2? You need to understand. You need to increase. You need to increase every item. You need to increase 2, right? So for every item, which one works? Map. If you see every line in the map, basically it rates over every line, right? So that is where this is one line, this is one, this is one. It works on every item. So how do that? I can simply do the, for example, I want to see, I want to lambda and want to increase by 10. So whatever I created over here, I want to increase by 10. For example, if you see RDD2, right? RDD2, I want to increase by 10. So now if I execute this one, you see all 10 been added to every line, every item. So what is it did? X plus X10, that's it. X means for each item in that RDD increase by 10, that's it. So it just increased.
Okay, sir.
If I use flat, what would happen? It will give all the now on top of I can use flat also, right? If you see uh, RDD4 equal to RDD3 dot flat map, right? Lambda x of now I can give x dot split, right? We did somewhere here split, if you remember. You see split here, right? Split by x dot split by space. Now here I can give x dot split by comma. Where is that? Right. X dot split by comma. That's it. Now if I give so you need to be very careful while working with copy paste. What happened? It is didn't work. Okay, there is a problem like that. So this is how you will apply multiple maps. So there is a map being applied, and on top there is another map, flat map being applied. Okay, so that's how you will work with the narrow transformations. It is similar to data frame, but very little different that you need to be identified and then work accordingly. Okay, so tomorrow we will deep dive into the wide what we call wide uh, transformations. Okay, and then accordingly we will proceed. Any questions, guys?
No, sir.
So how was your practice, Sunita?
Yes, sir. I'm going through YouTube. There are no videos are updated in this the link which you guys provided. So I'm just
So
going
can
through
you
the.
can you check with the Madhu? You know Madhu, right?
Yes, sir.
Can you check with him?
Sure, sir.
Because see, the purpose is not to go through YouTube videos. The purpose is to go through our videos, and you need to understand, right?
Yes, sir.
Because in YouTube, if you go, you will be lot of confused. You will get confused,
Yes,
Yes,
sir.
sir.
right? So don't go through that. If you have any questions, reach out to me.
So, sir. So
Okay.
instead of wasting the time on weekends, there is no videos updated, no. So I just gone through the YouTube.
Correct. So if you okay, so you do one thing. If you check with Madhu, still you didn't get it, give me ping me your Gmail ID. I will directly give you access to all these things.
Sure, sir.
Okay.
Yes, sir.
Okay. All right, guys. So let's we can resume tomorrow. Okay.
Sure,
Thank
sir.
you.
Sure. Bye.